Hi guys, welcome to the sixth part of the Formatables Refactor. We had a bit of a break, as usual family stuff getting in the way of coding. So, actually to be honest, we also had a little presentation that we did in Portuguese about research and so on, so it was a bit of a busy week last week. Anyway, so we're back on Formatables, and again without sound, sadly, due to our problems with YouTube. So if you remember, on our last video we created a new transform which was the lovely named legacy paths transform, and that transform was basically kind of a combined hack that contained all the code we had in locator pretty much as is. We didn't really make much of a refactoring effort because remember this is just temporary, and then to make the second bit of the hack, we created a set. Let's just double check that we are recording. Yes, we are. We created a set of enumerations that enabled us to dispatch based on the type of the artifact. Now, none of this is needed in the new world, but we are bridging the new world with the old world, and the quickest possible way is by just creating an enumeration that enable us to identify the type of the artifact and then dispatch it to the right function to create the path. And if I remember rightly, when we did this, bad things started to happen. Let's have a look. Yeah, so as you can see here, I have a lot of breaks. Okay, now then, so let's just go through these and try to understand what's going on. So archetype does not have a kind. Presumably what's happening here is that our hack is not comprehensive enough, as you can imagine. This is probably going to be where we're falling at the moment. But we need a bit more of a clue as to which archetypes I'm missing. So there must be some kind of conversion. Yeah, there we are. So we take an archetype name and then we get the archetype kind, which will probably be one of these guys here. Right, okay, here we are. So oh, okay, that's interesting. Let's just go back to this error. Right, so I think we just didn't look carefully enough to the output of the log file because, yeah, here we are. So this is actually telling us which archetypes don't have a kind, but interestingly enough, it's mentioning not the archetype name. So what we're sending here into these methods is the archetype name. I wonder if we are qualifying the name perhaps, or not qualifying the name, case maybe. No, it's the non-qualified archetype name. Okay, cool. It's a bit surprising that exception does not have a name. Maybe we just got missed. We have exception header. Okay, I wonder what's an exception header. Oh, so it seems that the archetype name does not include the prefix head. Now that's very curious. That's not really expected, because archetypes are really the lowest level of identification. It should really match the thing that it is. So let's try to understand why it is that we got an archetype with the name exception. So going through the regions, what we probably need to do here is we probably need some logging, I think. So this is a physical meta name. We could probably do something like debug processing archetype few bits of identification, such as the so if we have a meta name, there must be some kind of ID, hopefully, and we could just print the value. We could probably say something like the AN. Right, so this will, oops, not the AD, but the AN. This will hopefully give us some information of what's going on. The second thing we want to probably do as well is, well, we know it's one test failing, and that test is this guy here. Probably just basically the very first test. So what we can do is we can just locate this symbol and find the test, which should probably be the very first one, and then we can just set this guy to debug. Now what that will do is when we run the tests, it's going to generate a log file. We normally have that off by default, but okay, now if I just hop over to my log file area, that's my shell, and locate the log file. So the log file is sent to be in stage bin, and then always takes us a few seconds to understand where. So presumably it will be the orchestration test, byproduct test. Okay, here we are, and it's tracing this guy here. So around here somewhere, you're going to have an error. Ah. Right, okay, it's actually not as complicated as we thought. It's just we can't actually do C++ without doing C# because all the archetypes are bundled into one single meta model, and what's happening at the moment is we are trying to process a C# archetype. Okay, that's not a problem. I think it's probably quite an easy thing to do. For good measure, we will leave that actually as debugging. And then what we'll do is we'll go back to our transform. So the problem we have at the moment is that we need to parse or to handle the cases for the C# archetypes before we can proceed. As you can see, there's a number of these here. Now, they seem to be simple enough. I think you probably have about 5 or 6 of them. So what we'll do is we just have a quick look at what the naming conventions were. We violated the 80 column rules around here, which I don't really like doing. So let's do a quick fix of these. I must say it's quite difficult to program without music after many years of coding with music. Now then, the problem of course will be if there is a case where the C# archetype has the same name as the C++ archetype, we will have a problem. Perhaps that doesn't happen actually, maybe just by luck. Right, so what we'll do is we'll grab a few of these and see if there's any logic to this. Yeah, probably around here I think. So project and solution we already have, and those are the same. So we'll need a class enum, exception, primitive, and built-in. Right, so class enum, exception. I think we're missing primitive. That will do. Right, so then, let's probably put a bookmark here. So class enum, exception, class enum, exception, primitive, and built-in. And we fixed these names to match what the archetypes are. Now, of course, you could say, why don't you match on the full archetype name? That would avoid any problems. This is the hack, and we're just trying to do this to get it to work quickly. By matching on a partial name, it means we can grab a few in one go. So if I just take all of these guys, and then in here, all of those other guys are probably going to match. Interestingly enough, no, actually I think this will be okay. So if we just take these guys here, and if we just say that we don't particularly need the string bits, and to be fair, we probably don't need, we can't do this, so let's try something like, I think I went a bit too far there. Right, so we're trying to say something like, for each of these guys, so if the archetype name is one of these, yeah, so let's get saying if the archetype name is one of those, and I probably can get away with doing two in one line, save the lines and all that, then we probably want to return, these are all going to be C# things, so either C#, no there isn't one yet. So what we need to do now is we need to go back to the physical model, look for enum hack, and create C# implementation perhaps. And then what we need to do is also to double check that the C# locator, so if we go to C# and we look for the equivalent locator, this will also be doing some similarly dodgy stuff, and should, so as you can see here, we have full path, we don't even bother to call it C# implementation because they're all the same, so it doesn't really matter. Right, so what we'll do then is we will just quickly generate everything, and then just have a quick look at our C#. Interesting, I think we didn't save. Let's see. C# implementation, there it is. So, now then, this guy will now return C# implementation, and now the question one I have to ask is what do we do with it? Now I think the problem is going to be we don't really have processing for it. So I wonder how this guy knows about the C# path. Is there a .cs around here? Yes, here we are. So there's the extension, and presumably on the full path it will be adding the extension. So what we need to do then is we need to create a new method in our locator. Remember, this is a copied C++ locator. So we just need to create a new method here that could be copied from here. And I'm just, for good measure, going to put it at the very bottom. So I think we are in Portuguese keyboard. And this chap is going to basically, well, to be fair, we could probably copy most of the C++ header one. It's just going to be different extension, which makes me think that perhaps we should not call this extension. Where is it? Well, I'm not quite sure how its extension is being obtained, but we shall put it here. Right, so then, what is this chapter doing? Make inclusion, why do we call it inclusion path? I think we copied the wrong thing. We meant to copy. Right, so where are we? We are here, just before facet directed as you'd expect. But the thing we copied should have been something like make full path for header. These names are very difficult. You can definitely tell there's something alright with all this code. Include directory, implementation directory, templates, CPP header. Oh yeah, this is the guy we should have copied. Now, interestingly enough, this guy is then saying make inclusion path. Of course, there will be none of those things for C#. So, right, we can't actually copy inclusion path, but I think, well, I'm really guessing here, but let's see what happens if we copy the implementation path. We copy the relative one. This is actually hard work. Make full path for C++ implementation. Okay. Now then, okay, now what is this guy doing then? So, make full path to implementation directory. Looks sensible. Now, this is where we can't use this guy here. We will just hardcode that to be CS. That's about it, really. Now, odds of this actually doing something sensible are probably close to 0, of course, but that's not the problem. We just need to get something out. Once we got some output, then it's very easy to make it better. We just need to convince the code generator to attempt to generate some paths, and then we can try to understand where we've gone wrong. Right, now then, return to our test. So this should grab all the C#, well, when I say all, maybe we probably missed assistant. That's about it actually. If we just add assistant, it might solve our problem. Interesting. Most interesting, we are actually failing on something we haven't touched. So before we go anywhere, let's just make sure we add assistant to our list. And then we just need to add assistant here. That's about it, really. Now, we don't quite know why we are failing on this operation, so let's just run the test again after our change. Don't really need to run all the tests, really. We should let's just see if it's possible to just run just the one test, the test we care about. What are we doing for time? 20 minutes. So let's have a look at the log again. that's interesting. So we are processing a namespace header, and we seem to have a dodgy operation in that. Now I have absolutely no idea why it is that we are getting to the operation. So if we try to place ourselves in the chain of transforms, we are at the moment attempting to modify the legacy path transform, which is part of the mobile population chain. And to be honest, I quite prefer these things to not a straight line. I don't know why. So the legacy paths transform executes as part of the model population chain, and is going to at some point be replaced by the paths transform, which is the proper way of doing this. The operations transform will execute somewhere else much after we finished with all this about the population chain. So it's not entirely clear how we broke operations. So the first thing we do before anything else is we will just make sure that we did definitely break things, and that's by not executing our transform. So if we don't execute the transform, does it work? Clearly it's going to be true, it works, but just to double check. No. Okay, fine, that's not a problem. We will just convert Dogen.physical dia to JSON, and then we will indent this guy. Right, so we just want to make sure we're not being fooled by spurious errors. This is just basically archetype kinds. Let's just get rid of it. So we could say physical add archetype kind for C# files. Okay, so that gets rid of that. And then what we can also do, not quite what I meant to do there, really not. Okay, I seem to be struggling with my keys today. Right, what we really intend to do here is to run the test again. Make sure the tests are completely green before we do anything else. That way we know for sure that it's us that's breaking them. Okay, now you can see no problems with the tests. And now we run this guy again, and we will break on the operation. Now, we need to understand why it is that by changing the file name, we're breaking the operation. Let's make sure that we're not touching operation in any way. But we are including this is file system operation. This is fine. Although I don't think we need file system operations, do we? Let's have a look. Don't think we need this include. Oh, we do. Canonical path. Okay, no problems. Now then, not entirely clear to me. Perhaps what we should do is we should have two paths actually, just to avoid confusion, because I think what's probably happening is that we must have a decision for the operation based on the path, which is not ideal, but there you go. And that is now failing because we're not populating some path correctly. So let's just create something to represent the path. We might even have it already. So file path is what we're populating right now. Ah, here we are. I knew it created something for this. So there's this thing called path properties, which we're not using just yet. So instead of populating the file path, let's just get the path properties out of the archetype. So I'll just do something like this. Path properties, and that's going to be path properties. And then whenever we are doing this, we want to do pp dot. Now, the advantage of this is that we now have two different places to populate the path. The legacy place and then, well, we have three different population mechanisms at the moment. The legacy that we're trying to get rid of, the new legacy, which we're trying to make, and the new code, the real code. So what we're trying to do at the moment is just to compare the legacy with the new legacy. And that's basically going to be here and here. So this should, in theory, not break anything. And if we were to make sure, let's just think about this. The order of this has to be that we are running this transform after the formatables have already executed. And that we can check. So the physical, so we have a model population chain here. And the model population chain will execute. Let's just have a quick look as to when this model population chain executes. So this will be somewhere in orchestration. Just have to think about this for a second. In orchestration, we're going to be calling. So the physical model population chain, I think, is a bit too low level. Let's just have a quick look at the orchestration model. So the text model production chain, logical model to text model. I think the text model production chain might be a good one to look at. So the first thing we do is we convert the logical model to the text model, and then we apply the text. Right, okay, so we have a slight problem here, I think, because I think that, so if I just LSP find definition of this guy here, I suspect we are applying the model population chain here. There we are. So the model population chain is being applied as part of the construction of the model. And while we're doing this, let's run the test again. So it's being applied as part of the construction of the model. And then after that, we then run the text transforms. And those text transforms are the ones that are actually going to generate the Formatables model. Which means that, so to recap then, if I go back to the, not quite that guy, but to this guy here, this here is where actually, let's just have a look, just in case we're assuming something here. So the model to text chain right, there we are. So the model to text chain then will run the individual text transforms. And yes, correct. That is correct. So okay. So first we transform the logical model over to text model. As part of that transformation, if you remember, we created the notion of the logical physical space, right? So the transformation of the logical model to a text model already contains the physical aspects of that model. And because of that, we already run a set of transforms that can be run initially for the physical model. As it turns out, one of those transforms is the legacy path transform, and eventually the new path transform. Much later on, in the legacy path, we will then, or legacy code, we will then run the Formatables transform, which is this guy here. Right, that will do all sorts of other stuff. and that is done as part of the text generation, which is the stuff we are interested in. Now, in order to validate whether our code works or not, we need somehow, at the end of running both transforms, we need to check the values for both types of paths, the path properties path and the artifact path. If they're different, the transform is failing. And where they are different, we need to understand why. So the easiest thing to do is to enable tracing, I believe. And if we enable tracing, we could look at the output of the text transform, which is one of these guys here. For example, the model to text chain. That's going to contain a lot of data. That's probably the easiest thing to do, really. Let's go back to our tests. And in our tests, what we'll do is we will update. Now let's see if I remember how this worked. We have a method somewhere here with a whole lot of defaults, I think. There we are. And tracing is the very first one. So if I just go, I don't really need that anymore. If I just go here and set up the tracing configuration. Right, so the reason why is because this test ends up, okay, right, this is not a very good test to debug because it's a tracing test. We already are doing some tracing. In fact, I think we are debugging two tests rather than one. Let's just go for another test. That's just a plain, in fact, to be honest, I'm even going to go as far as saying let's use a different set of tests. This is just a plain code generation test. Those tests are actually testing other stuff. This is the easiest one because it's just a plain. Oh, as you can see, we already are doing some debugging here. Keep forgetting to remove these debugs. They slow down the test. In fact, while we're here, let's just do a quick RG. So in here, if we just do RG, so if I just look for test log debug on C++ files and everything in projects, right, you can see here we are already a couple of tests where we wouldn't expect this to be the case. So this is one thing that annoys me slightly. I think it's possible to do RG. Yeah, I'm not quite sure how to use RG with we'll grab. Ah, okay, that exists, that is deprecated. See what happens if I try to use it. So if I just say, let's delete this guy here, and let's delete this guy here. Save that. Right, so now it's fine. We only have, so let's just name this area to RG. Okay, now it's good. So we are now, so it sounds a bit silly, I'm going to put this back, but now we know what we're doing. We're going to test the variability model. Let's just get rid of all the noises coming out of the area. Right, so right, if we rerun the tests, this time we have the expectation that the tests will pass because we are not populating the path. And also this also goes to show that the approach we're taking is not particularly brilliant. I mean, we've taken a very simplistic okay, that's very interesting. We've taken a very simplistic approach in Dogen. The objective really is just to make sure things work. But at one point when we actually fully understand the domain and how things work, we need to go for a more immutable sort of approach. Because what's happening at the moment is we're relying a lot on mutability. And we're mutating things as we go along. And sometimes what tends to happen is one transform mutates one part of the model, then the next transform expects certain things to have been mutated, and they will fail if those things are not there. It's exactly what just happened there. The transform for operations is expecting some values in the path, they're not there, and then suddenly you get these really strange errors. So this is not ideal really. Okay, so as you can see here, all that's happening now is we seem to have addressed the thing that was causing spurious error. And now we're seeing the real errors, which is we still have some archetypes that we did not handle, which is good. That's exactly where we wanted. So now if we just go back to our legacy path transform, we just need to add more stuff to this guy. May not be the fastest way of doing it, but okay, so no one's doing that guy yet. We'll do just the easiest possible way. Sadly, we're probably going to have a few of these problems. In fact, what is the difference between this bunch of definitions and the next? Not entirely sure. This does not have to be perfect, to be fair. We just need to need it to work. So it's fine to have this very messy and very ugly looking code. It's not a problem. What we really want is for the tests to go green, and for which basically means that at that point we're recognizing every single kind of archetype, and then for us to diff the paths to see how bad they are. So we just have to go through every single one of these until there's none left. And hopefully when we do so, we're going to end up, so these are the headers, we want implementation here. We probably should write a macro that says something like this, and then if we just say let's just name that macro, because I suspect we're going to use that once or twice more. The error is now. This is taking quite a long time. Oh, here we go. Actually, just as we created a macro, we didn't need it anymore. Right, so this is good news. Yeah, excuse me. Bit of water. So what this tells us is that we are now able to populate all the paths for all the different archetype types. We don't know if those paths are correct or not. Now, in fact, Venus, I probably could tell you with certain certainty that they are wrong, because when we populated the path, we... In fact, to be honest, there's one thing that occurred to me just now. We probably should be computing the path. Yeah, because we probably want to flip backwards and forwards between these two variables. So what we're going to do now is we're just going to do something really simple here. We're going to create a new method here, perhaps. Let's just say path for archetype. So static boost file system path for archetype. this will do is this will well, let's think about this. What do we need to get the path? Excuse me, for the archetype we need seems that we need two things really. The PM value, so a string, and a name, logical name. And at present we are relying on a string. So if I just say something like, let's imagine something like we're in physical already, so entities. Actually, it's probably identification, I think. Entities, and then we need something like logical name, perhaps. So we take the logical name, and then we take a constant string. Well, actually, to be fair, let's just do this properly. And instead of taking a string, we will take the physical ID, I think. Physical meta ID. Right, so that would be the right thing to do. Now, like I said, we don't really need this code to be the best code in the world. It just needs to work. But the reason why I'm going to make this slight refactoring is because I'm going to have to flip between populating the path properties and populating the full path in order to see how close we are to doing the right thing. So one thing we should have done clearly is to supply the physical name really. So physical meta name perhaps, and that would then be the physical meta name. And then from the physical meta name we can very quickly extract all the bits that we need. So we could say something like all of this goes into here. We don't need it to be static. So all this stuff goes into here, and then we just need to extract these two guys from here. Now then, what are we going to do in this function? We're going to do something really simple. We will say, we already have a logical name. We also have a PMN with an ID. And PMN with location, right? And we could easily get the archetype kind, that's not a problem. And now they have the archetype kind, we could easily say that there is a return value, which is our R. And then we could say, I mean, to be honest, there's nothing stopping us from just returning the value really, making life slightly easier. So if we just return whatever this guy's got, as you can see, this method now starts becoming a lot easier. One thing we don't have is a locator. Right, now we are going to be in a slight bother because we don't even know what a locator is, since it's internal to the implementation file, and we expose that method in the header file. So by trying to make things simpler, we actually made life more complicated for us. So let's try to understand how we can hack around this. Well, one way would be to supply the entire model and construct a locator. Not very nice, but it is quick. Second option would be to understand. Yeah, I think I'm just going to go for a second option, which would be class locator by reference And then I think this is valid C++. Let's hope it is. Not entirely sure that that's legal, but let's have a look. So Dogen physical transforms, legacy path transform, locate. Ah, okay. Perhaps it would be valid if we made it a bit more external. Yeah, okay. So if that works, then hopefully we can now do something like... Right, so let's just clean up this guy here now. Hopefully you can see what we're trying to do. We are just trying to compute the path and not actually worry about where we're populating the result of the computed path. And the reason for that being that we want to flip between one location and another. Like I said, all this code is just throwaway code, so you don't really want to make it too fancy. You want to make it as simple as possible. Even if there's lots of copying and pasting, that's not important. What is important is that the functionality of it is equivalent to the existing legacy code. It's just one step closer to the final shape of the code. So we just have to do a few of these tasks. I mean, of course, you probably have noticed that I could have created an Emacs macro for this already. I guess I'm being a bit lazy. But the code is slightly different. Sometimes I do like making macros for a lot of stuff, but I do find that sometimes we Emacs users try to automate too much. And sometimes it's just easier to just quickly do something by hand. Sometimes, not always. See, it didn't really take that long, did it? And if there's a problem, we throw, and that is it. Right, so then, I think we got something a little bit more sensible now. So this thing will compute the path for a given archetype. This guy is looping. So perhaps the log could also be done here. And that will be a PM id dot value. That's perhaps a sensible thing to do there. And then here, what we're trying to do then is to say, and now hopefully this will make more sense, pp.fullPath file path, sorry, that's why. And that's going to be equal to get path for archetype, and now I need the logical name, and I will need some physical name. Interesting, I wonder how the physical name was computed. Let's have a quick look at how this file looked like a second ago. One thing that annoys me is that we always get the wrong placing for the VC diff for some reason. Right, so here we are, so it's just the metaname of the archetype. Righty, so now then, if all has gone according to plan, what we've done now is we've extracted the code to obtain the file path, extracted all of that, so all the computation over to here, this nasty little hack, and that now means we can very quickly populate either the file path in the path properties or the file path at the top. with just a few lines of code. Now what we're going to do is let's just make sure that our tests are passing after these changes. This is already good to commit. This is another thing we always do in Dogen. You're not really supposed to commit when things are perfect. You just commit as you go along. As long as you don't break the test, that's fine. See how we're doing for time. About an hour. Okay, good. So as you can see here, all the tests are passing. The next thing we always do as well is make sure we build the code generator and make sure that the code generator generates and that no differences occur. Right, so as you can see here, we're in a good place at the moment because the code generator is not giving us problems. Now what we want to do is we want to make sure that all the tests that we're going to commit are... Let me just move the VC diff here to my compilation window. You can't see that, but I can. And then if I just go to the tests, right, for now I'm just going to remove this so I can commit all of this stuff. Right, so what we're going to do then is we're going to say something like work improvements to physical, no, to legacy paths transform, add missing archetypes, populate the paths path properties to avoid errors. We are fixing the transform. Okay, so this here will get us where we're going. Then here we're just going to say, so be very careful that we have actually removed. Yep, so orchestration, remove spurious, log debug. Okay. Finally, we could say physical enable legacy paths transform. That means now that we are always using the legacy path transform regardless of whether the result of it is being consumed or not, which is good. Which means that if something breaks, we'd know immediately, even yeah, that would tell us immediately when something breaks. So now we're going to go to the second step, which is to say, let's look at our code generation tests. Let's find one of them. This chap will do nicely. And in here, hopefully we'll see that we can enable tracing locally. Right, so now then, let's just put a fix me here, so that this time at least we remember. And now we run all the tests. So our objective now is to run just the variability model test with tracing, so that we can compare the outcome of paths from the legacy and the new legacy. We really should have proper names for these things. Right, so if we go up to our logs area, but this time we probably should really have a logs and a tracing area actually, now that I say that, because we are actually, let's just do that. We keep flipping between the two. So in area 9, let's call this Dogen tracing. Right, and Dogen tracing will be build CCC9 release state. Right, now then, so tracing information will be in the byproducts directory. Max is thinking. And here we want to look for the variability dia tests. And as you can see, there's a tracing directory here. So it's not the bootstrapping, but it's the physical model production chain we're interested in. And right, as you can see here, we have the logical transforms, and then we enter the orchestration. And right, here we are. So really, we're interested in this chap here. Now, I suspect this is going to be a gigantic file. 35 megabytes, not too bad, but once we finish parsing it and in JSON mode, the slight problem, in fact, to be honest, we probably made a mistake here. We should probably have gone one up. We are using the complete output of the text transforms. That basically means that we generated all the text for the files. That means there's a lot of data. We could have easily just jumped to the beginning of the text transforms chain, where we run the formatables, but prior to running the text transforms. Now, I don't know if the tracing subsystem is clever enough to do that. In fact, I'm pretty sure it isn't. I think that well, actually, no, maybe it is. Unfortunately, now we have to wait. Emacs. The biggest problem really is that the JSON files. The JSON mode struggles a bit with multi-megabytes files, which also brings to mind we should probably just change the shell output to just fundamental for now, and just use JQ afterwards. That probably would speed things up considerably, because JQ can process 35 megabytes in seconds. Really, JQ is not the bottleneck. It's mainly Emacs trying to deal with a 50 or what, I don't know how much megabytes that come out of JQ. See how long this would take. Here we are, and 75 megabytes. Just for good measure, what we'll do is, let's just change this to fundamental. And let's run the same thing again, just to see how much the JSON mode is delaying things. So that took about 2 or 3 minutes, probably 4 even. It is actually not noticeably faster. I thought this would be quite quick. Perhaps JQ is taking a while. No, still. To be fair, it was a little bit quicker. And now I think if I put JSON mode here, it's still very quick. Okay, not clear. It seems that JSON is now thinking. That's perhaps what happens. So it's probably some of the paren modes. Yeah, I think some of the paren modes is computing the end parentheses on a 75 megabyte file that takes too long. Emacs does have a thing called, while you're waiting for this, Emacs does have a thing called VLF. And to be fair, VLF is very interesting. In fact, VLFI, never heard of VLFI, but there is VLF. Very interesting. We probably should really look into VLF when we have the time. Okay, now then, we have our dump, post all the transforms. What we'll do is, we will try to locate. This is the entire logical model, I think. So we are only interested in the physical model, so immediately that gives us a bit of a win here. And then in the physical model, we are only interested in the regions, I think. It is rather slow to work with 75 megabytes, sadly. So let's see if we can get to these regions as quick as we can. Of course, there may be more than one model. Let's just change this back to fundamental. Apologies, but I think, fundamental clearly is much quicker. So you see we got all the... So what we'll do is we'll change this to fundamental, and then we will just do a bit of faffing around with this. First thing I wanna figure out is whether we got more than one model. So if I just do something like JQ dots and then models, what do I get with that? Hopefully a much smaller file, because we don't really need the whole of the logical model. Okay, actually not a valid. Let's think about this. What did I do wrong? So actually, to be fair, I thought that would have been valid. So object models. Not clear why that didn't work. Let's just try to get the first model in. Okay, there we go. First model. 69 megabytes, so we haven't saved very much. Root module. These entities are just so large that oh, actually, one thing we can do that saves us a lot of time is in the text model we can look for the... Yes, we could just literally just say, please give me the models, first model dot physical. Right, so this should give us a physical representation by regions of the model. And the region... Well, I don't think you can go any better than the region at the moment. So, give us a first model and just a physical representation. There we are. That's 27 megabytes. Now I think JSON mode can easily cope with 27 megabytes, right? Might have been a bit over optimistic here. Right, okay, so now then, while we do that, let's just have a quick look at the physical model and understand what a region looks like. So that gives us the artifacts by archetype. Suspect we can so if we just say please give me the artifacts by archetype, and then I think we could probably say the first one. No. So where we think we are at the moment is we think we got the physical model here. The physical model then has... sorry, we made a mistake here, we jumped a little bit too quickly. The physical model has regions by logical ID. Right, so what we really wanted to say is something like, please give me the regions by logical ID, and then I just want the first item of the regions, and then of the items of the region I want the artifacts by archetype, and that also I want the first. So hopefully okay. Right, let's again jump back one. Right, so where are we then? Right, I think we just got one artifact here, perhaps. Quite what I had in mind, but let's have a look at what we got. Profile bindings, provenance. Right, Right, so we have a type here, codec ID. Non-PDM reference. So that's the type. No, sorry, that's the model reference. So logical name, that should tell us what we are looking at. So, okay, we're looking at CMake lists. Okay, CMake lists, not entirely sure. We should be in a variability model, but okay, that doesn't really matter. What we really care about is all the artifacts by archetype for this guy. There they are. And in here, finally we're getting something sensible. In here we will have, interesting that there is no configuration, there's already a problem. The region does not have a configuration. At this point it should, so there's a bug here. Let's just write a note before we forget. Region configuration is no. I must say, I find company mode more of a annoyance when I'm writing text. Region configuration is null after text transform execution for CMake lists. Right, so we have to check this. Let's put this in autofill mode. Righty. So where we were was somewhere in tracing. So that's already an interesting problem. But really what we care about, okay, so file path is not filled in, most peculiarly. At the end of the text transform, file path is not filled in. Okay, that's very puzzling. But onwards we go, and we're looking for the path properties, which is also empty. So this is all very puzzling, really. It could also be that we just chose a problematic archetype. They include CMake lists. So what we need to do is we need to make sure this is not a random event. So let's try then to say, okay, give me all the regions, and then in each region please give me, so regions by logical ID. In fact, it's not entirely clear to me what this thing is giving me. So it's giving me the very first entry of regions by logical ID. Which is in itself a container. So I wonder if I then say, give me the second. Right, okay, cool. So now what you're seeing here is we just disregarded the key and we just went for the value. And then if I now say, please give me all of them, this is not actually going to make valid JSON, so I probably should have gone for fundamental mode. Would have been more sensible. So what we're trying to do at the moment is obtain every single artifact across all regions. Right, there we are. So this is clearly not going to be valid JSON, as you can imagine, but it contains everything we want. Now what we really want is to be able to go into these guys. In fact, to be honest, I'm just going to simplify things slightly here. Let's just stick to 0 for now. And then let's try to see if we can do something similar here. Not quite. It's not very obvious why this is not possible, because as you can clearly see here, you can maybe it is because we have this data business. So let's try data Right, okay, now then. Now this is clearly not the cleverest way of doing all this stuff, but alright, so we have multiple arrays going on here. So we want to say unpack the array, and then after unpacking the array, please give me number 1. Right, finally we got to the archetype. Now then, now we have an archetype. We could probably say something like this: tell me all the file paths. All of them are null. Very puzzling. And then we could ask a similar question here, but tell me all the archetypes file paths. And all of them are null. Okay, that sounds very, very puzzling. And now if I go to path properties, did we actually populate anything? Right, I think something's very wrong here. But first thing we should do really is to make sure we don't lose this query, because it took us a while to get there. Let's put the query somewhere safe. A query to obtain file paths. And it's something like this, or something like this. Right, so this is a good query, a very useful query, which we'll probably use again. But what is confusing at the moment is we don't seem to have much. Actually, that's even. I think this is probably not telling us the truth, actually. Shouldn't have done for every single artifact, but there you go. I think we've got a mistake in the query. The reason why it's null is because it's not finding it, rather than the fact the value is null. Sadly, I've done it for every single artifact, so now we're going to have to wait a few seconds, probably minutes even. Right, so before we go any further, let's just rerun that query with just a single element. And then yeah, probably this will give us 3 of these chaps. Yes, correct. Right, so we know what we're doing now. What we want to know is, why are we really showing the file path? Because I think we're not. Right, it's because yet again we have data. No. So what we wanted to do here is to go into the object. So well, right. So data.data.file path. Good God Almighty. Okay, we got it. So that is the right query. Not that one. And we're going to repeat this query now, but asking for the path properties, which is also empty. Right, now let's be brave and let's do the exact same thing, but for every single archetype. Cross-space. Right, okay, this now gives us a much more interesting picture. Now, what we're seeing here is that we have a lot of archetypes that are not populated, but a few there are. Right, so what we're going to do is we're going to just change our view here in Emacs, and right, so now let's think about this for a second. This is showing us that many archetypes on the space are coming out as nothing. Now, it is entirely possible that we are making a space dense. So let's think about this. What does this mean? we have an archetype space. We have this logical physical space. Not every point in that space makes sense. So therefore, and on top of that, not all every point in that space is initialized. So it is entirely possible that we are skipping some archetypes because they don't make any sense. We could figure that out by getting the archetype names, which we could do that in a second. But I'm more interested in knowing the diffs. I'm assuming this is the truth, right? This is the things that we think are correct. So we could take that and we could say, well, let's just call that legacy.txt. Right, let's just say that that's the truth. And now let's then say, go to the path properties, and let's see. Well, these path properties look very bad, to be honest. There's nothing on it, so we don't even have to worry about diffing. We don't seem to be doing much. Right, so the first thing we need to do is to make sure that we populate the path properties. So before anything else, how does the path properties in general look like? Rather blank, as you can see here. Right, so why are they blank? Are we sure we are on the right transform? So first let's just dig in the transforms a little bit more. Let's see if so around here there should be a logical model to text model transform. There's the chain. Right, now we should be able to very quickly have a look at the transform, the legacy path transform. Oh, and look at this. The legacy path transform is not here. Okay, it could just be that we are not running the legacy path transform. Let's just double check that we are. So if I just go to model population, the legacy path transform is just here. It has tracing support. It's correctly called legacy paths. Let's double check its transform ID. Correct. So I can't see any reason why this transform would not be tracing. So we should be here. Yet we're not. That's very puzzling. I'm not entirely sure why that would be, really. I mean, this could be something really silly. Let's just make sure that we are running latest. Run the gen extraction test. Let's rerun this again. We expect all the tracing files to be regenerated. As you can see, it's taking a little while, so that's a good sign. Okay. Now then, right. Update this directory. As you can see here, we are not getting an up-to-date timestamp. Right, okay, so it's fine, it's not a problem. We just made a mistake somewhere. Let's just double check that we are looking at the latest data. So let's look at variability.dia, and that's October the 2nd. What is the easiest way to know what the date is? October the 16th, so definitely not right. Let's just rename this shell. Leave it there. Right, now then, October the 2nd is definitely not a good date. So what we probably need to do is to make sure we're in the right place. Right, so what do we think then? So we know for sure this has been touched. We don't see, well, let's just look at every single permutation of variability we have here. So cogeneration variability, there we are. So what were we looking at? We were looking at physical production, cogeneration, alright, we just looked at the wrong place. Right, as you can see, this looks out here. Text transforms, cogeneration chain. Now then, in here, we should have the logical transforms model production, orchestration, text model production, and we're exactly in the same place. Okay, well, to be honest, we're not even going to bother with all of that. We're just going to take the output of this guy here and say, what does the file path look like? Okay, so that doesn't look very much different, which is what you'd expect. So we're going to do exactly what we did before and create a legacy.txt, right? And then we are going to now rerun this, but now we're going to say, give me the path properties. And hopefully now they're going to look much different, okay? So for starters, you see this is a dense population rather than the sparse one that we had a second ago. We seem to be generating files all the time, which we don't for the other case. And the second thing is, which is going to make our life a lot harder actually in terms of comparisons, because now, because we are generating all the time paths, oh, I see already there's some errors here. So now what we're going to do is use the good old empirical method and say, well, let's take something random. For starters, is the full path correct? It looks vaguely correct. So if I take something like the initializer, do I see this path here? Yes, I do. Well, I see it twice, interesting. No, just once. Okay. Actually, that doesn't look too bad. Let's take a few of these then. I mean, other than the fact we are doing a dense generation rather than sparse. As you can see, we are finding most of these paths here. Okay, so let's just do another test then. Let's just then say, let's call these the new, sorry, I meant to say new.txt. So new contains every single thing. Old, in fact, let's just rename that to old.txt. Old only contains the points that we're interested in. So the first thing I'm going to do is I'm going to say any line that only has quote quote, I don't really care about those lines. Okay, something's happening downstairs, 1 second. Okay, so then, what we've done now is we've got rid of all the stuff that we don't particularly care about, the quote quote stuff. And now what we want to know is, for every line that we have here, does it have a matching line in new? So we can just open up another shell. Well, let's just use a regular shell for this. And let's then say, let's say, I wonder if you can do something as simple as a equals cat new.txt for a in dollar. If I could type $a, do echo $a. No. Okay, perfect. So this is now showing me the contents of the file line by line, and then I could just do something like grep. So what I really want for grep is grep. Let's see, grep. Let's just see what grep minus help would say. I just want a quiet. Is there a brief? No, quiet. Quiet. Suppress all normal output. Only matching. I just want to know whether a file matches or not. So well, we definitely want the minus v, and then yeah, let's just try that. So if I just do something like grep minus expression in new.txt. But what I really want is, in fact, to be honest, before we do this, we're just going to start by saying head, so we can play with the smallest sample. And then we could just do grep minus v minus e $a on we made a mistake here. We really want to start with the old, not the new. On legacy, on the new.txt. So what does that do? It's showing us all the lines that match, presumably. That don't match, sorry. We really want is there is an option in grep that basically says matches or doesn't match. I'm beginning to suspect it's quiet, but I'm not too sure. So let's just try grep match or no match, something like this. Yeah, something like this. So, oh, interesting. Right, so that's probably will do us. But of course, that's going to print the results of grep. We really, or maybe if I didn't use that with minus quiet. Okay, right. So then, grep. So grep match that minus q and then or echo $a. Brilliant. Okay, so now according to this, it's basically saying that these guys don't match. Every other guy matches. So this is cool. First, let's validate that this is really true, because you never know, I could have made a mistake. So this is, let's make sure we go to the new file. Right, so you see we have loads of entries in this namespace, and the shell is telling us that basically the namespaces didn't match. So if I say entities.hpp, right, so it seems there was a bug of some kind, and yes, you can clearly see the problem here. The problem is the namespaces are not, there's some special handling for namespaces, and that special handling is not taking place. So we see two differences in behavior then. We have a lot more data, and we have two cases where we're not generating the right path. But all in all, it's not too bad. We are very close to generating the right data. So let's see if we could handle this scenario then, which is we need to handle the case where we're a namespace, and on the namespace we need to double up. We need to add the name of the namespace as well as to the file name as well as to the directory name. So the first thing we'll do is we'll try to understand how that happens in the existing locator, and we could just probably just look for the symbol. I wonder if I could, no, it's not a symbol, is it? Locator HPP and CPP, there we are. So what we're looking for then, we're trying to understand how namespaces get parsed here. So first, is there any reference to the namespace? No. So what must happen then is the locator must have some special ability, really. Well, actually, let's just write some notes before we go any further. Locator is now creating a dense representation of paths rather than a sparse one. We probably need to understand why that is. Namespaces are being incorrectly generated. Okay, cool. So these are the two observations we've done from the work so far. Now then, now we've done those two observations, what we need to do is to say, well, let's just start with the namespaces, because the dense versus sparse is probably not a big problem. It may be a problem, we'll see later. In fact, to be honest, I think that's what's causing the problem with the operations, but we'll ignore that for now. We'll focus on the one that seems to be more obvious. Now, we don't seem to have any special handling for namespaces here. What we'll do is, we know for sure that in text.cpp we have a special archetype for, well, I have an archetype for namespace, which is this guy, namespace header. So what happens if we take that template and then we have a quick look? No, there's nothing special about that template, how it's calling for the namespace path. It is just making use of the regular whale template, and that whale template is, you have to have a lot of state in your head, unfortunately. So the whale template for the namespace is going to be the usual CPP artifact transform header, I think. In fact, this guy here. So we take this guy, we have a look at its contents, and all that's doing is this, make inclusion path for CPP header. Nothing particularly special here, really. So then what we then need to do is to say, is there any handling of modules that is special? Add the model path to all the modules that contain this name. Models other than the model module contributes, here we are. Models other than the model, okay, right, fine. So I think we probably, okay, right, so we probably are, right, so this is the key bit here. We copied the logic, to be fair, we have copied the entire logic here, so it should have worked exactly the same way. Somehow it's not. So presumably the isContainer flag is what's causing the problem. Now we know for sure that's being populated correctly because this comes from the guts of the logical model. It's very unlikely that we are not populating that correctly. But to be fair, there's not a lot else that could be going wrong here. So well, that's just as usual, add some tracing. So we need something like module name. Well, not adding module name. Okay. So that would do us. Now then, we need to go back to our tests, .cpp, and in the variability, we need to debug, go back to our logs. So what we need to now know is try to understand why it is that we're doing this differently in the new world, or in the new legacy world, shall I say. It's getting a bit confusing. We are running a little bit long on time. Didn't really want to have 2-hour videos, but righty. So is this up to date? Let's just double check that we have got the right log file, which I don't think we have. So let's find the right log file, which will be in stage bin log contribution tests, and that is correct. Now then, we should be able to just obtain the guy we're interested in. Log files are quite large, as you can imagine. So what we'll do is we will obtain only the relevant bits. We should have probably changed the mode for Shulkman output. There we are. Now then, let's look for something like entities. Not entirely trivial to find entities in the middle of this confusion, given so many things have that name in it. So, but we do have the archetype ID, so I wonder if I just do something like mas.cpp.module. No. Types module? No. Oh, is there any reference to a module? Must have processed the module somewhere. Yes, this is a module. So, right, that's the guy. So here we are. This is the guys we're interested in. Right, so namespace header, so here we are. So, full path to the include dir. Right, let's just look very, very carefully what we're saying here. So, processing archetype, namespace header, the guy we're interested in. Full path to the include dir. Well, that's probably alright. Inclusion path prefix, Dogen identification. Making facet path, Dogen identification helpers. Done making facet path. Right, this is very interesting, isn't it? We did not hit any of the code that supposedly handles the logic. It's very peculiar. So let's just then look at how namespaces are being handled. Because I think they're not being handled correctly. So namespace header. Well, a namespace header is definitely a C++ header. So that sounds good. Not very special. Not entirely sure why it would be different, but there you are. A C++ header is definitely make full path for C++ header. I mean, it would have a lot of errors if it wasn't. So there must be something special for namespaces that we're missing here. Because there's no way we could, there's no difference there really in the processing. Oh, actually, sorry, just before we continue, let's just, before we do that, so we know for sure, we look for already, right, this is what we know for sure, but what happens if we look for not? Right, so what's happening at the moment is, making facet path is adding the not adding module name, but yeah, so we seem to have a different way of making facet path here. Why is that? I mean, it has to go in one or two paths. Let's just double check that we're not missing an adding module name. It's very peculiar. So it should have been here. We don't have a not, but we don't have adding either. I mean, this is an if, so it has to be one or the other. So the only conclusion is we're not calling this method. Or we are calling this method, but we're exiting before that. There is no return statements prior to this. Is there two methods for making making facet path temp? Right. Yeah, there's a lot of hackery, unfortunately, in all of this stuff, and most of it is lost in the midst of. So there's two methods that look very, very similar. Yes. Can't quite remember why that is. So I think what we should probably do is make sure we call the right names. So at least we have a chance of knowing which one's which. And then let's go here. Okay, right, let's try again then. This is really not ideal, but we must keep in mind that this is all temporary code. This code that is used to experiment, not really code that's going to stay. Sometimes you just need to prove a point very quickly, rather than make it perfect. It's only. So if I just stop for a second. Right, where were we? So now then, if we rerun our query and see what the log file has to tell us. We seem to right, okay, cool. That looks good. Now let's look at our namespace header. Okay, cool, there we are. So the namespace header is not adding module name, this is exactly where it was expected. And this is why it's generating the incorrect name. Right, now then, why? Well, there's only two options. If n is different from model name and n is container. So I guess all we need to do is to make sure the container is set correctly. Now, as I said before, I have no idea why the container flag would not be set correctly, but it is possible. Oh, okay, let's think about this. Probably what's happening is that we are copying the logical model name from somewhere, and that place is not being set up correctly. Has to be the container flag, clearly. Okay, sorry, I need to put a pause here. Right, sorry for the break. Quickly go back to where we were. So, yes, we were just about to try to make a search for namespace header, and we wanted to see is container set to false. Right, okay, so that explains it. Now then, let's go back to our notes. Remember to write this down. This is because the logical name is not correctly annotated with a container. Is container flag. Oops. Right, where are we then? So why is it that we're not annotating this correctly with the is container flag? We have to think of how these logical names come to be. So in the case of the legacy code, we are using directly the name as obtained from the element. So that's known to be correct, that's not a problem. However, in this particular case, we're using the name as it's coming from the region, if I'm not wrong. So the region itself, as we've already seen, the region has already got a bug. The configuration is not set correctly, so that's a bug. Most likely they're not. The region itself, which has a provenance, right? And that provenance, let's just double check what we're using to as the name here. So we are going through the region's biological ID, and then in the region we have an archetype, and we get the region.provenance logical name, right? And then the logical name is used for everything here. Now that it should work, there's no reason why it should not work, but it's not working, and the reason why probably is because the logical name that we're grabbing in the region is not being updated correctly when the region was generated. So the region gets generated as part of the transforms. So most of these problems are going to be in the same place, presumably, because we generate regions when we're transforming from logical to physical model. So now we have to make sure that we're doing this region at the right time. I mean, it has to be at the right time, surely, because by the time we get to convert the logical model to a text model, all the logical transforms have already kicked in. So that's not a problem. Logical to physical projector. So the logical to physical projector then should be responsible. Let's see what logical to physical projector. Fuzzy match is not the best. Right, so let's see what this chap's doing. So we're grabbing this ID, create the artifact set. So physical region, right, so in the region we have the logical element E. Oh wait, of course, we have to remember that we're looking at the physical representation of the logical region. So physical representation of the region. This contains both the physical and the logical representation, and that's why that's there. The physical region is here. The provenance is generated here. Oh, very interesting. Why do we... Right, okay, so this is just silliness, really. For whatever reason, we seem to be manually... All sorts of very strange things are happening here. So the logical meta name is being generated manually. And the name is also being generated. I mean, I have no idea what we're trying to do here. So, it seems much more logical to me to basically say, and in fact I don't see any reference to the configuration here either. Okay, right, so this looks very, very bad. I would, without remembering this code very well, just say something like e.meta name, and then something like r.logical name e.name. That would then mean that we don't really care about any of this or this. Now we just have to be very careful about what else we're doing here. So the qualified name, so it's not obvious why we need a QN at all. This is all legacy code, I'm afraid. This code that has been evolved. See, we are still populating the logical ID, which comes from logical names, all done. The logical name dot location. Yeah, again, we don't need any of this. Okay, cool. So I'm not entirely sure why we're doing all this sort of stuff, but there we are. And then this is just the provenance. So I think it's fine to have this method to make the provenance as we are doing it. But what we need to then remember is, yeah, we are populating the configuration here. So it's not entirely obvious why there are cases where the configuration is not populated, because we should always populate the configuration according to this. Let's just nevertheless rerun the tests. Hopefully what this will now show us is we don't even have to go through the whole process of reading the dumps. We could just see what the log file says. Yeah, and as you can see here, it's now adding the module name, and this now looks correct. Okay, so that's the fix for this. Okay, doc. So we noticed that they had two problems over the data coming out of the new path transform. The first problem is we're populating too much. We're populating every single permutation of archetypes in physical space, which we wouldn't before. And we also noticed that the namespaces were not done correctly. So we fixed the namespaces just now. Let's have a quick look at what we got now. Diff. Right, so there's the fixes for the namespaces. This is all the tracing stuff. And that's a bit of additional logging. So we probably, I think the logging is fine. So add more logging around modules. Well, we can leave it there. It's all legacy stuff anyway. This is not so fine. And here we want to say orchestration, fix, provenance, generation for a region. Right, now we don't really need tracing on tests anymore, and hopefully what we'll see is if I run all tests, everything should be green. I mean, of course you know everything should be green anyway because it was green before, but we just want to make sure we didn't break anything. Okay, as expected. Now then, what we're going to do now is, as I said before, we're going to do some hackery around here. And I wonder if autofill mode is on here. Yes, I don't know why. Right, now then, so if I just say that A file path, what this will do now is populate the original file path. Now then, this is going to break stuff, and the reason why we think this is going to break stuff is because before it was breaking stuff related to operations. I suspect what's happening is that although the paths are all more or less correct, yeah, maybe. So I think what's happening now is this: because we're populating every single path, and because in the past we were relying on an empty file name to filter things, we're no longer filtering based on the file name because the paths are now being populated, which then results in some artifacts that prior to this were not being really processed correctly to still be processed. So let's just think about this logically. What's happening is this: when you try to expand a region of logical physical space, in fact, to be honest, I think this video is already taking quite a long time. Maybe we can just make a break here, because everything's fine for this task. I think we'll just take this as a separate task. Okay, so just to conclude then what we've done in this video, then we figured out that there was so we're trying to move away from the existing locators that we've got that exist in each of the namespaces, one in C# and one in C++. The ideal world is that we got rid of locators altogether, and that's the future, and that's how it's going to work. It's all going to be data driven. At present, that's not possible because there's lots of dependencies that need to be sorted out. So we are trying to do an in-between step where we get rid of these locators, we move them over to a transform called legacy paths transform, and this will be equivalent in terms of the code that's being, in terms of the data that's being generated to the stuff that we got at the moment. But it will take us a step closer to the final, to the end result. And with this now is we managed to make sure that all the paths that are being generated are correct. However, we're generating too many paths, and so that's where we are at the moment on this Refactables, Formatables Refactor. Okay, hope to see you in the next video.